all of you for being here, and thanks for giving me the opportunity to talk about what we've been up to. What we are going to talk about is some of the work we've been doing in blueberry breeding in general, but specifically about shock. And so we've had funding from the commissions in Oregon and Washington to do both, to work on blueberry breeding for advanced selections and cultivars with cultivar potential here. We've also been asked to sort of try to figure out whether we can do anything about breeding for whatever you want to call it. And we'll talk about that a little bit, whether it's resistance to shock, tolerance to shock, slow to get shock. We'd all love immunity to shock, but we know, or at least the research has been done previously, suggests that's not going to happen. So I'll go through each of these sections. So Tom already sort of gave an overview of blueberry shock. You know, some of the early work was done by Bristow and Martin, you know, when Bob was still up north of the border and Pete Bristow was still working for WSU. Did a lot of the characterization of the virus and how it was moved. We know it's a pollen-borne virus. You know, once it infects a plant, it's transmitted by bees or other pollinators to the flower. Once the plant's infected, part of the plant will lose, all the flowers will die when they break bud in the spring. It may take a few years to move through a field, a few years to move through a plant. One of the interesting things is, as far as this bud death or flower death, that only happens once on a given part of the plant. We've never seen it recur, although there's been some investigations into some times when people thought it might be reoccurring. It may take a long time to jump from one block to another. I know when Bob and Pete were doing that initial work, they, you know, had blocks where, I can't remember the varieties, but it was probably blue crop, took forever to get it. But in general, once it moves into a field or into a variety, it moves through that variety fairly quickly. And it makes sense. It's a pollinating insects, everything's blooming at the same time. You're going to get a lot of it moving around. But for the challenges we have is, you know, there's a lot of variability in how quickly different cultivars get it, different genotypes get it. We know that. We can't control a pollinator vector because obviously it makes no sense to kill all the bees. And, you know, there have been people who've talked about, why don't the nurseries pre-infect the plants and send them out so you never have to go through this shock stage? And people have talked about that. But for any of you who are anywhere close to a nursery, you know that, you know, the departments of agriculture, and for them shipping overseas and for them shipping to your neighbor, for you to plant next to a neighbor that has no shock, that doesn't work. So we haven't figured out a way to deal with shock that way, although it would be nice. So just some field symptoms. I think you're all pretty familiar with these. The flowers come out in the spring, then they blast off. It can be just a few flowers, or it can be the entire plant. You'll also often see that shepherd's crook that we so often associate with Pseudomonas, seems to often be associated with shock virus or occur at the same time. We do see recurring foliar symptoms. All these slides show this spotting you get on the leaves. So even though we say the shock symptoms never reoccur, that's not true. The killing of the buds never reoccurs, to our knowledge. But you often, you know, certain varieties, I think 1613A, for instance, really shows this red splotchiness that people thought for a long time might be some sort of fungal disease, but just seems to be a shock symptom. So we sort of thought, well, can we figure out ways to breed for tolerance? So we started off when we first began this, we asked the industry, you know, what things seem to be really slow to get it? And this is about 6 or 7 years ago now. And you see ones people thought, like Brigida, Blue Gold, Liberty, were very prone to getting shock. And then things like Legacy, Jersey, Burlington, Baby Blues, we were either known from research plots or from grower fields that they just didn't get it very fast. Interestingly enough, early on, growers thought Draper was slow to get it. And so that's why it's on the low list. But we know now that Draper gets it pretty readily. So, you know, how do you start on this? Well, first you start testing all of our, you know, the germplasm we have in our breeding program. You know, in many years, not all years, but ever since Bob moved from Ag Canada to the USDA back in 1895, we've been sampling the blueberries in our fields. And so we don't do it every year, but we've done it enough. We've gotten much more regular about it the last few years. We've done our breeding plots, what happens at the North Willamette Station, and then also at the USDA National Clonal Germplasm Repository, which is in Corvallis, which has a field collection of a wide diversity of blueberry germplasm. And Joseph Postman at the repository is sampled there. But the big question is, what is good? And how do you decide? Is it, are we going to wait 25 years and say, okay, it doesn't get it for 25 years, that's pretty good? Is it, if it holds off for 6 or 8 years, is that good? If it gets it in the first year but shows no symptoms after that, the first year in the field, is that the best thing? If you just lose a crop on a 2 or 3 year old plant, that's a lot better than losing a crop on a 7 or 8 year old plant. Unless you're blue gold, where sometimes you almost keel over and die after you get it when it's a really young plant. So I throw that out there without an answer. We still struggle, and as you see how we present the data in some of these, we still haven't figured out a really good way to evaluate this other than wait a really long time, which isn't very satisfying. So, we've done these kind of samples, and I'm not gonna make you go through all these, but to identify these, do you look at the number of years it was shock negative and then the number of years it was shocks positive? So for instance, Aurora up there, which you can barely read, it was, it's been in the field for basically 8 years, and it was six and a half years shock negative, and then it's been shock positive since. So it took almost 7 years. You get funny averages because we have multiple plots, and that's why you get some averages. The ones that, here you have Aurora, which was identified by growers as slow to get, and yet in our research plots, they got it in about 7 years. Is that slow? Is that good? I'm not sure. I would really like you to weigh in on this. And then we have something like Elliott, which was identified as slow to get, and yet in our blueberry plots, it took about 7 years to get it, but it's been, infected for another 7 years. So that's sort of one way to look at it. Graphically is sort of the way I'm feeling most comfortable with it right now, where you look at all the years it's been in the field, all the years it's been tested, and then you look at how many years it has shown symptoms or been tested positive. And obviously some of those that are very long bars with very little red on them, such as, G344 took over 20 years to get shock. And Legacy has yet to get shock after over 18 years in our plots. And then there's some other ones like Recca that are pretty slow to get it. It went for over 10 years or 11 years before it finally got it. So that's a way to do it, but it's still not a very satisfying way. And then if you look at selections, just to be clear, you don't need to focus in on any of these, but this is a 0 to 10 year timeline because we haven't had these selections in our program for that long. But you can see that there are, almost all of them that have been in the ground for more than about 6 or 7 years are getting a little bit of, have tested positive for shock. So that seems to be about when we're getting it. On the other hand, one of the things I'm not showing on this is there are some things that are terribly susceptible. I don't even have it on this slide, but if you look at something like blue gold, it usually has it 2 years after, really the first bloom in our fields that usually must get infected. So the take homes from sort of this pool of information is we have found things like baby blues, this list of cultivars that have been repeatedly identified either in our plots or repository, North Willamette, Corvallis, as being slow to become positive with shock. You have a group there that are really rapidly get shock. Cargo being the one that was just spectacular this year. We had no shock last year, no shock symptoms. It didn't test positive. This year, 100% positive and not a fruit on any of the plants in our fields. But it seems to be rebounding very quickly, and I expect it to be okay next year, so maybe that's a good thing. In all this research, we know the southern high bush and even low bush are slow to get shock. That may not do us that much good in a breeding program because we're not going to use low bush. I can't imagine using low bush in breeding program. But southern high bush is also questionable. It's got some good fruit quality, but do you really want to deal with the cold hardiness? But nonetheless, it may just be that they're escaping shock. The southern high bush and the low bush bloom extremely early. It may just be that they're blooming before there's any shock infected plants in the field blooming. So then we start looking at the repository, which has broader germplasm base. It's a world collection of vaccinium. And we're not going to go into detail on this, but there is germplasm, particularly in something we call the GEMS trial that we've already used for breeding. This is germplasm that's tolerant of mineral soil. And it's those US 612, 693, 845, And quite honestly, some of those have been useful in breeding programs. I think, I'm getting it mixed up now, but either Cargo or one of the other new Fall Creek ones has a US 845 as a parent. And so it is pretty advanced breeding material. And so we have used that quite a bit in our crossing. Material that's wild species from Maine or North Carolina seems to be very slow to get it. You sort of hate to go back to that kind of material because it's usually soft, the scars tear, they're dark blue, lots of different negative problems, but we have messed around a little bit with those. And as I said before, while the lowbush blueberry vaccinium gustav folium is slow to become infected, it also blooms very early. But this does give us some material to potentially work with. So we've done a bunch of crosses among low and very low susceptible materials susceptible to germplasm that's slow or really slow to get the material, to get the virus. And we keep evaluating selections. As we try to evaluate the parents, we're sort of trying to look at, can we look at some of the populations from legacy, the offspring of legacy? Are they likely to transmit slowness to get shock or not? And what you see over in this column is the good news is something like legacy, which we said repeatedly is slow to get shock. You know, a lot of the offspring are slow to get shock. You know, the 11 selections from legacy were pretty slow to get shock, but none of them didn't get shock. It was most of them, you know, the good news is that, you know, 82% of the legacy offspring selections in the first 7 years after we selected them got no shock. So there seems to be some transmissive of that, although then you look at some other selections that are like Elliott, which, you know, it's supposed to be slow to get shock, and yet it's only about half the offspring are slow to get shock. So there seems to be something there, but it's hard to pin down. In an ideal world, we'd be using genomic tools, and we have a population of what we call a jewel by Draper population that we're trying to, you know, if we could, instead of waiting 20 years, figure out what the mechanisms are and use genomic tools to screen for slowness to get shock, that would be great. You know, we could screen our seedlings or screen our selections without having to wait that long. It's never that easy, but that's the theory. Unfortunately, the University of Florida breeder who we're working with on this just got hired by Driscoll's. And so it's going to be a couple of years. That's going to take a bump in the road before we can get back to evaluating whether we can use those tools. We'll see. So that's sort of where we are in shock, and be happy to answer any questions after the end. I'm going to talk a little bit about just in our program, the development of new cultivars and where we are in that process. We do crosses in all our breeding work in Corvallis, and then all the selections go up to the OSU at the North Willamette Station near Portland, and I invite you to come down and see that plot anytime. We also, as things start to look, they're separated by about 60 or 70 miles. At the North Willamette Station, we tend to manage things very much like growers would. In Corvallis, we plant the plants, and 3 years later, we evaluate them, and 4 years later, and then we tear them out. And so it's more a matter of efficiency there rather than right up to grower standards. We plant the seedlings. This is how the process goes. You know, we get them out to field size, transplant them out, and then we go through and make selections, and fields look pretty brutalized after you're done. You save about 0.5 to 1% of your seedlings as selections. Over the last 4 years, we made about close to 150 selections. Most of our goals are in high bush blueberry breeding. We have messed around a little bit with rabbit eye blueberries, and we have a few pretty promising selections. They're only going to fit in tiny niches. And then we also have had some interest in ornamental or germplasm type work. Things that look good are at the North Willamette Station, where we invite people to come for field days. And anytime you're down there in June, July, you're more than welcome to wander through the planting. We're getting ready to put in a whole new planting. As far as selections that look promising, I'm not going to go into detail on these, but we have 3 selections that we're trying to clean up to put into grower trials. It's 264-1, very high quality, late high bush. It's looked good in a couple different locations. We happen to put some plants at a grower field and down the valley a little bit, and they still look good. And then we have a couple different rabbit eyes, which I know that's of limited interest, but there's also lots of room for easier improvement in rabbit eyes than in northern high bush. We have a series of other selections that have looked very promising in our trials. You know, breeders are always saying, wait till next year, and we are guilty of that as well. But it's nice to have our breeding program rolling things out into advanced trials and grower trials. 235-3 is one that if anybody's interested in trialing this selection, we have hundreds, not thousands of plants, and we'd love to get them at some farms. We've already got some farms targeted up here, but if you're interested in trying it, please let us know. It's got that outstanding fruit quality that aromatic flavor we often associate with some of the southern highbush blueberries. Got that pop that people like to eat. It's great flavored. It's yielded well for us in our trials, and IQF, it's done very well. Main concern is bush habit, and I think the bigger concern, although it's never been a problem in Oregon, is, especially for up here, is it's got a lot of southern highbush in its background. And so I'm worried, not worried, I want to know how cold hardiness issues it might have. And so I would like to get some sites that are a little more cold hardy, and I'd rather get it fried at this stage rather than a number of years from now after there's lots of acreage out of it, or have it not come right through in flying colors. So certainly let us know, and if you got a business card, love to get some plants at different places. We did release Baby Blues, and having said that, we're going to have to change the name. Between the time we submitted the patent and they reviewed the patent 2 years later, somebody named a baby blue ornamental blueberry that's a ground cover that is only planted in backyards, but the patent office won't let us use Baby Blues. So I, in the next 7 days, have to come up with a new name, because otherwise we have to start the patenting process on it all over again. And I just got the documentation a few weeks ago. So if you have any good names for a very small fruited blueberry, outstanding flavor, great yields. In our trials, it's yielded like Liberty. Liberty before it started to go backwards, back when Liberty yielded well. It hasn't tested positive for shock yet. I think we had our first plant in one trial test positive this year after 18 years. Like I said, it's about half the size of blue crop fruit, not half the size of yield. Vigorous, high quality. It seems to be machine harvestable very well in simulated trials that we've done. And it's been out in a number of different locations and looked good. It survived in Michigan. I wouldn't say it's thrived in Michigan. So I don't know how people who are on the east side compare themselves to Michigan. I know very different, but also cold. This berry is either of great interest to you or absolutely no interest to you. It's a small fruited berry. I know that there's not a huge market for that, but if you are looking for small berries, competing with the low bush market, doing that kind of bakery operations, dried operations, it could work very well for you. So I'd welcome new names. You know, some people said just name it the French thing and call it Bébé Blues, and we'll just use the American pronunciation, which is Baby Blues. I don't know. So that's been our objectives and what we've been up to, and we've for those of you who know, I'm love to be here. I'm love to be live and kicking. And thank everybody in the commissions and the different nurseries for all the support they've given us. And if you have any questions, please let me know. Shock is spread by pollen. Pollen-borne virus, so bees move it. Or any other pollinator. Any other questions? Okay, there you go, Henry. Are you the moderator? Or do you want me to introduce the next speaker?
You may, if you'd like, you know.
I don't know the topic, but I'd be happy to introduce him.
You could say stories.
Well, because before he, you know, he said we're going from the sublime to the ridiculous. So now what are we doing this time? We're going back to the ridiculous? Okay.
Well, yeah.
Tim Miller is going to come up here and talk to you, and he promises to stay on time this time.
Yes.
Because he knows that all that's standing between you and a happy hour is him.
Miller.
And while there are very